Okay, here is part 2 of our lesson or section 2.2 videos. In this video we're covering parallel and perpendicular lines. So go ahead and pause the video really quick and take these definitions down. These first two definitions for parallel and perpendicular lines. We have that two lines are parallel if and only if they have the same slope. So when I say two lines, we might call them like L1 and L2. So then they have slope m1 and m2. So if they're parallel, m1 is going to be equal to m2. That's the mathematical way of saying that the slopes are the same. Therefore, they're parallel. Okay? With the case of perpendicular, it's a little different. Two lines are perpendicular if and only if their slopes are negative reciprocals of each other. Okay? And here is the mathematical way of saying it, but then kind of remember that the two slopes are going to give perpendicular lines if one is different sign and they're the reciprocal of each other. We can flip that fraction. So an example, just to kind of show you right off the bat already, if one slope is, let's say m1 was 4, then m2, if these lines are perpendicular, would have to be negative, change the sign, and then take the reciprocal, 1 over 4. Another example, let's say m1 was negative 7 over 3. m2 would have to be positive 3/7. Okay, just to give you examples of what it means to be perpendicular. Okay, let's apply that and what we learned in the first video to this example. I forgot to say in the first video that was example 1, well, this is example 2. Okay, example 2, identify whether the lines are parallel, perpendicular, or neither. Okay, go ahead and jot that down really quick. Pause the video if you have to. And here's our first example, part A. Line 1 goes through 3, negative 1 and 6, negative 4, while line 2 goes through negative 4, 5 and negative 2, 7. Feel free to draw yourself a picture of that to visualize it, but let's go ahead and give this a try. We're going to say line 1 has slope m1 and line 2 has slope m2. So then let's go ahead and calculate both of those slopes. In order to figure out whether these guys are parallel, perpendicular, or neither, we're going to need to find both of their slopes. So let's start with m1. m1 equals y2 minus y1 over x2 minus x1, negative 4 minus negative 1 divided by 6 minus 3. Okay, so negative 4 minus negative 1. Let's rewrite that first just to make sure we're on the same page of what that actually means. Negative 4, when I subtract the negative, I'm technically giving that number back. If I take away negative 1, I'm giving you 1. Divided by 6 minus 3. Okay, what does that give us? Negative 4 plus 1, that's going to be negative 3. 6 minus 3, that's positive 3. 3 divided by 3 is 1, but then negative. So we have negative 1. Let's find our m2. Okay, 7 minus 5 divided by negative 2 minus negative 4. Minus negative 4. Equals 7 minus 5 is 2. 2 minus negative 4, I'm taking away negative 4, which means I'm giving you that 4 back. So negative 2 plus 4. Negative 2 plus 4 is positive 2. 2 divided by 2 is 1. Okay, m1 is negative 1. m2 is positive 1. Does that look like they're the same? No, because one is the negative of the other. Perpendicular. Well, let's check. 1, that's technically 1 over 1. Same with 1 over 1. When you take the reciprocal of 1 over 1, you get 1 over 1. So 1 is its own reciprocal. So the reciprocal checks out. Now are they opposite signs? Yes, m1 is negative, m2 is technically positive. So these two lines are, in fact, perpendicular. Okay, nice. Oh, I didn't mean to cross that, sorry. Let's do one more example with you just so you get the hang of it, and then I'll have you try C, okay? Again, m1, m2. So let's find our first slope. 0 minus 2 divided by 5 minus negative 3. Hopefully you already have the hang of subtracting negatives, okay? I know it's algebra 2, so maybe some of you are like, oh, Mr. G, I already know how to do this. But, just kind of making sure. No one is left behind. 0 minus 2, we get negative 2. 5 minus negative 3 becomes 5 plus 3, 8. Okay, don't leave it unsimplified. Let's simplify. What goes into both 2 and 8? That would be 2. Divide both of those things by 2, our numerator and denominator. To simplify, we get negative 1 over 4. Okay, so let's think ahead a little bit. If these two lines were to be perpendicular, what is the m2 that we're looking for? Well, m2 should be positive 4 if these lines were to be perpendicular. If they were to be parallel, we want m2 to be the same. We want m2 to be negative 1/4. So what that means is that if m2 is neither negative 1/4 nor 4, then we're going to classify these two lines as neither. They're just intersecting. Okay, now that we thought ahead, let's see what the actual result is. Negative 3 minus negative 4. Divided by 3 minus negative 1. Okay, negative 3 minus negative 4. 3 minus negative 1. Okay, negative 3 plus 4. Negative 3 plus 4 is positive 1. 3 plus 1 is 4. Okay, remember, what were the values that we're looking for? It either has to be positive 4 or negative 1/4. The answer we got is positive 1/4. Okay, so since it's neither of the first two numbers we just mentioned, it's a neither. Okay, that means that these lines, all they do is intersect. There's nothing special about the intersection. Okay, it's not a perpendicular intersection, and because they intersect, they're not parallel. Okay, now go ahead and try part C. Go ahead and jot that down and give it a shot. Okay, and then meet me in the next video, which is the last video of section 2.2.